Assalamualaikum and very good evening to Encik Afdal and to all my group mates. Today, we will like to present about our project, which is Ping-Pong Launcher. First, we will like to present about introduction. So I will pass to Navindren to explain it further.
Thank you, FATIN. My name is Navindren. So now I will present about the introduction. In this project, we will determine the spring stiffness and make it as a piston concept. For example, when a particle is projected in the air with some speed, the only force acting on it during its time in the air is the acceleration. This is because due to the gravity. This acceleration acts vertically downward. There is no acceleration in the horizontal direction, showing that the particle's velocity in that direction remains constant. As we know, projectile motion is a predictable path followed by an object that is mainly affected by three factors. The first factor is the initial launch speed, second is the launch angle, the third one is the gravity acceleration. Gravity is the most important force acting on a projectile. This is not to say that other forces does not exist, just that the gravity effect is minimal in comparison. Based on our projectile motion, when we pull the nut behind it will mate with forcefully. The spring fixed with the nut hold the ball until release the ping-pong ball launch forward, which is 1.5 meter. Angle, direction, time, velocity, energy conservation, and so on are the example of this concept. Second, I will proceed to the mechanism of projectile motion. As you know, projectile motion is a type of motion that an item or particle experiences when it is launched near the Earth's surface and proceeds along a curved path under the influence of gravity alone, with air resistance believed to be negligible. There are a variety of examples of projectiles. As we know, three examples. So the first one is the projectile is an object that is launched upward at an angle to the horizontal. Second is the projectile is an object that is thrown vertically upward. The last one is a projectile is an object that is launched from its resting position. The photo which we attached there is the ping-pong launcher designed by our group. So, to develop this mechanism, we have used several materials to build it. For example, we use wooden plank, PC pipe, door hook latches, door hinge, bolts and nuts, steel band, screw, PC cap, also spring. That's all from me. I will pass to AFIQ to continue this part.
Thank you, Navindran. Now I will proceed to course section of the ping-pong launcher. This is a simple drawing of the ping-pong launcher. I will explain more in the video later. This is the video, the demonstration of the ping-pong launcher.
Hello, my name is Muhammad bin NASIR. I will introduce to you about our ping-pong launcher from my group. As you can see here, we use a PVC tube with a PVC cap here, 40 millimeter. Inside here we have a 25 millimeter cap. Between them we have a spring. As you can see here, we use a string attached to this ring to launch the projectile, which is a ping-pong. The angle here is 45 degrees, as you can see here. So we got the maximum range from this launcher. I use screw and nut here to make the angle. So we also can adjust it from different angle by rotating it. That's for the launcher iteration. I will proceed with the demonstration video. Thank you. Hello, now we are going to do the demonstration part. As you can see, the launcher is 45 degrees to the ground, and the target area I have put a shoebox to raise it to same level as the launcher. Yes. Yes. Ooh. Oh, too far. Oh, baby. Yes. Ooh. Oh, missed the target.
That's all for me for the demonstration of the ping-pong launcher. Next, I will move to calculation part by AQILAH.
Okay, thank you, Afiq. Okay, my name is AQILAH and I will explain furthermore on calculation. So for this experiment, there are two parts of calculation. First is finding the velocity and time of flight, and second is finding the spring allocation, which is x. Okay, so for the first part, since I attach here the image, okay, firstly, we assume that the x-axis right become the positive. So we use the linear equation s equal to s naught plus v naught t. Okay, s is the final distance, which is 1.5 meter. S naught is 0, and v naught become v cos theta, which is theta is 45 degree, the angle of the launcher. Okay, after the calculation, we got the first equation, which is v naught equal to 2.1213 over t. Okay, for the second equation, we use y-axis. We use another linear formula, which is s equal to s naught plus v naught t plus half ac t squared. Okay, for this part, since the ping-pong ball launched forward, there is no final distance for the y-axis, so it becomes 0. And then the same thing, v naught becomes sine 45 degree, and AC is the acceleration, which is the gravity, negative 9.81. And then we got the time of flight, t is 0.38 seconds. And since we got the t value, we just substitute it directly into the first equation. So we got the velocity, which is 5.59 meter per second. Okay, for the second part, we are using v naught plus t naught equal to v1 plus t1. This is the initial and final energy. Okay, so we have to know that the v is the potential energy, which is half kx squared, and then t is half mv squared. Okay, so for the first part, which is the initial part, t naught becomes 0. Because of what? Because the initial velocity is 0, so everything will become 0. Okay, for the second part, for the final energy, the final elastic potential energy becomes 0 because it is moving. It's not at the rest state. So finally, after substituting all the value, we got x equal to 0.1 meter. Okay, for this part, we have to find k, right? So k we got from the second experiment, which is the spring elongation. Moving on to the next slide, please. Okay, so this is the data. This is the graph that we make from the data. Okay, for this part, we use the gradient to find the k, which is spring constant. And using that, we substitute the k value into the previous equation. So we got 0.1 meter. That is our theoretical value. Okay, for the experimental value, which is what we have done, we got the same value, which is 0.1 meter. After calculating the percentage area, we got 0% error. So that's all from me for calculation. Moving on to the next person. Thank you.
Okay, thank you, AQILAH. My name is FARHANA, and I'm going to explain further about discussion and conclusion. Okay, for calculation, we use a few types of formula. First one is linear equations formula. Okay, we use a linear equation formula in finding the velocity and time. The relation between velocity and time is a simple one during constantly accelerated straight line motion. Constant acceleration implies a uniform rate of change in the velocity. The longer the acceleration, the greater the change in the velocity. Change in velocity is directly proportional to time when acceleration is constant. If an object already started with a certain velocity, then its new velocity would be the old velocity plus this change. Okay, second one, we use Hooke's law. In finding the spring elongation, we use Hooke's law and also the energy and the simple harmonic oscillator, which is kinetic energy and potential energy, as stated in the slide. Okay, Hooke's law is the force exerted by the spring. The external force we exert on the spring is F external equals to Kx. Slide before. Okay, stick to this one. Okay, in a simple harmonic oscillator, the energy oscillates between kinetic energy of the mass and potential energy stored in the spring. In the SHM of the mass and spring system, there are no dissipative force. So the total energy is the sum of the potential energy and kinetic energy. In this section, we consider the conservation of energy of the system. The concepts examined are valid for all simple harmonic oscillators, including those where the gravitational force plays a role. Okay, next slide, please. Okay, lastly, after plotting a graph, force versus extensions, we make some calculations in finding the gradients and also the percentage error. The gradient of a line, or more generally a curve plotted on an xy axis, tells us how the change in the y value of the curve depends on the x value. So we use formula as stated in the slide. After that, we calculate the percentage error. The purpose of a percent error calculation is to gauge how close a measured value is to a true value. Okay, next we move to conclusion, the last part in this slide. Okay, we relate projectile motion using initial velocity and the angle we use to launch the ping-pong ball to find the distance that the ping-pong ball should reach from point A to point B. In conclusion, our ping-pong ball launcher had an initial velocity of 5.59 meter per second launch at 45 degrees, giving us no percentage error at all. That's all from us. Thank you.